So last time we talked about how to calculate confidence intervals for the population mean. If we wanted to estimate the average weight of all the pink elephants in the world, for example. And the formula we used last time was based on the normal distribution, and it had one big kind of flaw in that to use that formula, you have to know the population standard deviation. Problem with that is that often you don't know the population standard deviation. After all, if we were trying to estimate the mean weight of all the pink elephants in the whole world based on just a sample, because we didn't have access to the whole population, well then, how are we going to know the standard deviation for the whole population if we don't have access to all the pink elephants in the world? So today, we're going to talk about what you have to do differently if you're estimating a confidence interval when you don't know the population standard deviation. Now we've got our sample of pink elephants, and you can calculate the standard deviation of that sample, but that would be S, the sample standard deviation, rather than sigma, the population standard deviation. So the big difference between what we did last time and what we're doing today, if you know the population standard deviation, and remember that the symbol for that is that Greek letter sigma, then you use a z interval, which is what we were doing last time in section 7.1. If you only know the standard deviation of your sample, and the symbol for that would be just S, then instead of using a z interval, you use a t interval. And that's what we're going to talk about today. So the formula for a confidence interval when you don't know the population standard deviation is slightly different from the formula we were using last time. It looks a lot the same, but there are a couple of things different. One of the differences is that there are S's where there used to be sigmas, and the other difference is that there are T's where there used to be Z's. So to use this formula for confidence intervals, we have to know the sample standard deviation, that's what we put in for S, and we have to know what number to put in for T sub alpha over 2. And that's what I have to explain now. So instead of using Z sub alpha over 2, which is based on the standard normal distribution, that T sub alpha over 2 is based on something called T distributions, which are similar to normal distributions. They have sort of the same shape, except that they don't go up as high in the middle, and they have fatter tails. They don't flatten out as quickly as you go off to the right or to the left. And you have different shaped distributions. It says T distributions, plural, because there are slightly different shapes to the distribution for different sample sizes or different what's called degrees of freedom. So the exact number that you'll be using for T sub alpha over 2 is going to depend on your confidence level, like whether you're doing 95% or 99% or whatever, and on on sample size, but it's going to be given in terms of what's called degrees of freedom. And all you really need to know right now is that for degrees of freedom, you're going to be using the sample size minus 1. Now we're going to be reading off the numbers for T sub alpha over 2 on table F that looks like this. If you have the important formulas card, that came with the book, this is one of the tables on that card. If you have your book itself, it's one of the tables in the back of the book. It's table F. And I did give you a copy, or I did post a copy of the important formulas card on Canvas. So if you don't already have that on paper, you can go on Canvas and find where that important formulas card is. And this is one of the pages of that card. It says Table F, the T distribution. And if you look at the top of the table, it says confidence intervals, and then it gives 80%, 90%, 95%, 98%, 99%. And right under that, it says something about one tail and two tails. Ignore that for now. Just focus on where it says confidence intervals. And then running down the left side of the table is a column that has DF at the top. DF stands for degrees of freedom. And like I said, that's going to be your sample size minus 1. So, for example, if you were finding a confidence interval with confidence level 95% and your sample size was 15, degrees of freedom would be 15 minus 1. It would be 14. So you would find the row of the table for where degrees of freedom is 14. And you would go across to the column with 95% at the top, if we're doing a 95% confidence interval. And the number that shows up there in the table is 2.145. So that's the number that you'd be using in the confidence interval formula for T sub alpha over 2. Let's try another couple examples to see if we've got the hang of this. What is T sub alpha over 2 for confidence level 99% and sample size 28? If you want to, pause the video while you try to find that on the table. You're going to be looking at the row where degrees of freedom is 27. And you're going to be looking in that last column with the 99% at the top. And the answer should be 2.771. Okay, let's try another one. What is the T sub alpha over 2 for confidence level 98% and sample size 20? Again, pause the video if you want a little time to try and find that on the table. So you're looking at the row where degrees of freedom is 19, and you're looking at the second to last column that has the 98% at the top, and the number there is 2.539. So if you know how that works, then we're ready to find some confidence intervals. Find the 99% confidence interval for the population mean if you have a sample of size 16 whose mean is 312 and whose standard deviation is 13. Now, when it says whose standard deviation is 13, that means that's the standard deviation of the sample. That's S, not sigma. So that's why we're doing a T interval instead of a Z interval. So here's the formula. X bar is the sample mean. And here that's 312, a sample whose mean is 312. The standard deviation of the sample is 13, so that's S. It's a sample of size 16, so N, the sample size, is 16. And to know what number to put in for T sub alpha over 2, it's a 99% confidence interval. Sample size is 16, so degrees of freedom would be 15. And when we look on the table, find the row where degrees of freedom is 15, go across to the 99% confidence interval column, and the number that shows up there is 2.947. So T sub alpha over 2 is 2.947. Now let's put this all into the calculator and get our confidence interval. Okay, here goes. X bar is 312 minus T sub alpha over 2 is 2.947 times, in parentheses, although you don't really need the parentheses, S is 13 divided by the square root of 16. And that gave me about 302.4. Now the other half of the interval, the upper limit, is the same formula, but with a plus instead of a minus. So if you can go back and edit your entry to change that minus to a plus, that comes out to 321.6 if I round to the nearest tenth. So my confidence interval is from 302.4 to 321.6. Mu, the population mean, would be somewhere between those two numbers. Now, if you have a graphing calculator, you can take advantage of the special built-in capabilities it has of doing this for you. So if you're doing it that way with a graphing calculator, push Stat, go over to Tests, and go down to T-interval. Last time we used Z-interval, this time we're using T-interval. So if I select that, make sure you're on Stats instead of Data, and go down and put in 312 for X bar, 13 for S, N is 16, our C level, our confidence level is 0.99. It's 99%, but we have to put that in as a decimal, 0.99. Now move down to calculate, hit enter. It's got to think about it for a second, and then it gives the interval 302.42 to 321.58, which agrees with what we got from our formula. So the calculator method, press Stat, select Tests, and select T-interval instead of Z-interval. Select Stats, type in the appropriate values, move the cursor to Calculate, and press Enter. I'm going to do one more example, but this video is already getting kind of long, so I'll finish it up in part 2, the next video.